Hello, everyone. Thank you for joining me here today. My name is Marco Bonezzi. I work in MongoDB as part of the technical services team. And I'm here today to talk to you about how we can make the most of our mobile application data by using MongoDB Atlas and by now using MongoDB Realm. And in particular, we'll be seeing how we can use MongoDB Realm sync for our data. So let's get started. The idea of MongoDB Realm is it's the part of how we have a common point of focus when we think about MongoDB, when we think about Atlas, and now when we think about Realm and Realm Sync. So the goal of this product combination is to make it easy for you to build powerful and engaging experiences on more devices. And if we go back and think a little bit about MongoDB and Realm, I'd like to cover how MongoDB, you probably all know, it's a general purpose document-based database that it's built for modern applications and built for the cloud. And the goal is to make you productive building applications and experiences. When we talk about Atlas and as well as Stitch, the idea is that it's built for agile teams that prefer to spend time building apps rather than managing databases manually, as we used to do. And when we bring it now around to the picture, the idea is that we can build better applications even faster. So this is the main goal of this version of MongoDB with Realm, and in particular with Realm Sync. So today I'm going to share with you a story. This story is from my brother, Gabriele. He is studying physics in Paris. And he is like a very driven, very interested in areas outside of physics. And he's not a DBA or he's not a mobile developer, but he had an idea for a new application. He felt that his idea had potential and he would love to implement it. But the problem was how to get there, how to actually start implementing it. One day, he showed me a video from a few years ago about MongoDB and giant ideas. So thinking about it, he was like, well, actually, this time I need to make it. And this is something that Gabriel and I have been speaking about for a while, making apps and how to actually get them done, which never happened. So his idea was to have a system for smart gardens telemetry. So what this means is that he'd like to gather and monitor garden conditions to track their development and growth based on the weather conditions. So how he wanted to do this? The idea is to use Raspberry Pis with a sensor for temperature, humidity, pressure, and GPS. And then additionally, those Raspberry Pis will be fixed there in on site. The idea then is that there will be devices used like iPads or phones for, say, weekly on-site inspection. That could, for example, include picture of every garden, of every plant in the garden and other condition as well. And by doing this, we will be storing and sending data live to a central repository for tracking and analysis purposes based on these different conditions. So he started with some research, and as I said, he started this idea by seeing a video of Giant's idea and using MongoDB. And of course, he knows a little bit of MongoDB because he's my brother. I speak to him about MongoDB. So yeah, he started looking at MongoDB in terms of where to store his data. So he started looking around and looking at the website and seeing what he could do with MongoDB. So he saw that there is the database, that it's relatively easy to use. It's based on a document model, so it's interesting and it's simple to use for the use case that he's thinking of. So that's great. It has a query language that is very expressive and driven to help developers understand and query the data in an easier manner. So that, of course, helps as well. Then there are other aspects that he is not interested in, but it definitely helps if his idea gets bigger. So things like replication, where you have multiple copies of your data, it's something nice to have as well. Looking at the website, and speaking about replication, there are also options to have like high availability by design, which as his idea ideally will grow, it will be relevant as well. The goal of MongoDB, from what he was reading as well, is that it can be run anywhere. So he can start with his own laptop, playing around with it, but then running it on the cloud if needed. And one of the aspects that was more interesting for him, given that this was like an initial idea, was the concept of scalability and how this is a flexible environment that can grow as applications grow. So by looking at the MongoDB website, then he started looking into Atlas. And I was like, actually, this looks like even simpler to use. So it's a self-service and elastic data platform, which means that he can go into a UI and start playing with things and get a database ready for him. So he started going through the documentation available and playing with the UI, and he saw that okay, like by default, when you define an instance, this will be a replica set deployment, which without configuring anything, it's pretty good for him. It's all based on automation and the best practices from MongoDB, which that also it comes handy, and you don't have to worry about how the setup is done. But then there are other aspects that started to get him more and more interested. The fact that it can be used by usage, it's definitely interesting. He's a student, so he can start small with that. There are aspects like migration. If you start off the cloud and you want to move there, that's definitely useful. And then other aspects like monitoring alerts, auto scaling if things get bigger, full text search, which he wasn't too sure what that was about, but it definitely sounds like something cool to play with. And also a concept of triggers, that it seems that it can automate a few things based on the data, and he really made a note of checking that and how he could use them for his application. So he was thinking, and he was after seeing this information on MongoDB and Atlas, he was like, okay, so this is like the technology that I want to use, but there are some aspects that I need to deal with for my application. There are certain conditions, like for example, what if the connectivity is lost? The Raspberry Pi devices have 3G connectivity, but what if something happens to that? How it will reconnect? The other aspect as well is like how to make sure that the application is continuously sending data without having to implement too much code or too much network retries and so on. Because as I said, he's not a DBA, he's not a mobile developer, so he doesn't know and he doesn't want to get too much into code for that. The idea for his application is that each garden will have weekly reports, which means adding more information on site, like pictures, for example. The data should be synchronized in two ways. So this solution should handle updates from multiple devices, but at the same time, both from the clients to the main central repository, but the other way around as well. When we think about devices like iPads or Raspberry Pis, the idea is that the application needs to be battery friendly and ideally multi-device. So it can be run on IoT devices like Raspberry Pis and similar, and at the same time on others like iPads or Android devices. So these were the conditions he had. So continuing with his research, and looking at MongoDB and Atlas, then he saw Realm and in particular Realm Sync. And he saw that comments from users that the goal is to have happy users, and if they are not happy, they won't be using that application, which resonated with him because his goal was to make an application that was used by many people and make it useful, not just for him, of course. So then he started looking more in depth into Realm and Realm Sync, and he saw that it seemed to meet all the requirements and conditions he had, like offline first application, background sync into a central repository, uh, conflict resolution, two-way data sync, and the fact that it was a concept for offline first applications, which in his case, that might happen. So Gabriele, after seeing MongoDB Atlas and Realm, was convinced that this was the technology he had to use for his mobile application, and was really pleased to see that the features provided by Realm Sync were addressing the concerns that he had for his project. In addition to this, when researching more and more about Realm and how Realm Sync work, he was pleased to see the feedback from the community and how Realm Sync was probably the right thing for him to use for his application based on the sentiment and the comments of the community. And that made him feel that he was making the right choice, which is something important when you are starting with a new application. As part of his research into Realm and Realm Sync and how it works, he read that sync is implicitly happening on writes, that data is efficiently exchanged by being compressed and by sending only the changes at the field level, and how it overall Realm Sync significantly simplifies building applications that have sync and real-time collaboration features that users nowadays expect in any app. In addition to this, Realm made very easy to work on cross-collaboration, cross-platform apps, like whether it was JavaScript, whether it was iOS or Android. As part of his additional research into how Realm Sync really works under the hood, he found that there are two main aspects. One is the Realm database on the client side, and then Realm Sync. On the client side, it's very easy for developers to learn how to develop with the Realm SDKs, and this really simplifies working with data on mobile devices and taking into consideration the constraints we have in those type of devices. And it also ensures that developers can build apps that will work regardless of connectivity, which was a requirement for Gabriele for his app. Remember the Raspberry Pi running with 3G connectivity and sending data from the garden. So, the connectivity might drop at some point. So it is important to be able to do these offline first applications, and Realm really helps with this. In terms of Realm Sync, it offers us effortless bidirectional sync between MongoDB on Atlas and the Realm client. And this is done by using the automatic schema generation that translates your MongoDB data into data for any client. And this technology works cross-platform, whether it's Android, iOS, JavaScript, or other technologies. Realm will take care of it. Gabriele continued reading more and more. He's very keen at getting to the bottom of everything. So he started reading existing use cases on how Realm was used. The first use case that he read was about real-time features and how with Realm we could build reliable applications with feature database that is on the mobile device, providing us the ability to read and write data directly on the client. And then once we have a connectivity, that will be sync with other clients, and how the changes are replicated as soon as the write is committed on the device, which is pretty cool that it's handled by Realm for us. The second use case is exactly for offline first applications, where we can use Realm Sync to build collaborative or multi-user applications that need updates in real time, but can also handle situations where one of the clients will be initially or temporarily offline. In addition to this, we don't need any particular code for conflict resolution, as this is handled automatically by Realm. And overall, it will ensure that the application and sync is optimized for the technical constraints that we have on mobile devices. The third use case was about five-star applications. Five-star applications means that the user experience of a mobile app is key for the users. And this is where developers should be spending most of their time, not on handling network, not on handling conflict resolution, but on making sure that the user experience is exciting for the users, it's useful. And then by doing this, Realm provides an integrated database and sync solution, which means that developers can now work on focusing on the user experience and making sure that their apps will be really close to getting those five-star reviews on stores or marketplaces for our applications. So after reading all this information, Gabriele was definitely sold on using Realm Sync, using MongoDB, and using Atlas. So to resume and review all the information that he learned, he thought of putting together a summary to capture all the information, all the details that he learned in terms of MongoDB, Atlas, and Realm Sync. So in terms of doing a recap and seeing how it all fits together, on one side, we see that we have MongoDB and the new release 4.4. Okay, this is all running on the Atlas platform. It's a cloud database. Makes it all easier to use and easier to deploy. So that's perfectly fine. And then we have the additions of the Realm database on the client side, and then in between we have MongoDB Realm, that it's an added piece here that has developer services previously known as Stitch that provide authentication functions or triggers, and then Realm Sync, which provides the magic sauce to make data sync happen. So looked complex, but he was confident that he was going to be able to achieve and use this technology for his idea. So once he finished this research, the next step was how to get started, how to start creating an app using Realm Sync on Atlas. So after all this research, after all this information, and after learning more about the technology, he was now even more convinced on making his idea reality. So following the documentation on the MongoDB side, on Atlas, and on Realm, he identified 4 main steps to follow to achieve this configuration. So first, setting up a new MongoDB cluster and creating a new app in Atlas, then architecting the classes and structures required for his applications. Once he had that, he will need to code his application in some programming language. He was confident that using some of the documentation, he will be able to achieve that. and then configuring Realm Sync on the Atlas UI for his application and run the code. So seems relatively straightforward, 4 steps, a lot of them from the UI. So he was positive, he will continue and go with it. So the first step is to create a new cluster. So when we go to cloud.mongodb.com, we have like a very simple UI where we can, with a few buttons, create cluster, select which region we want our cluster with, which cloud provider, and then the specifications of that cluster. We need to make sure that we use MongoDB 4.4 as Realm Sync needs MongoDB 4.4 to be able to function. But with just a few clicks, we are able to create a cluster, all configured, all with the best practices from MongoDB in Atlas. And once that is ready to go, we have this nice view where we can see operations, this usage, and so on. And it's very helpful in getting us connected and getting us to access the data. So this part was easy. The next part was to define the classes and the structures. And the UI really helped with this, but at the same time, with the examples and tutorials at mongodb.com, he was progressing and making sure that he continued to define the use case. This was something that he had the use case very clear in mind. So within a few minutes, Gabriele described the classes and relationships the way he saw in his idea. So he defined the schema, then the schema on the Atlas side as well, and you could even define relationship, for example, between a garden and the plants that will be within that garden, which was like what he wanted to monitor and measure. So now we get to the part of developing some code for our application. So as I said, he's not a mobile developer, but he has done some programming in college and outside of that. So he was looking at which option will be the best for him. In this case, he saw that he could do this either in Java, Kotlin, Swift, Objective-C, JavaScript, or .NET. And he decided that JavaScript was probably the easiest for him. So he went to the documentation, got started installing Realm with NPM, and then playing with the sample code to understand how Realm works and how to start defining data models in Realm. And after a few days of coding and getting his head around how things work, he was able to define the model that he had for his idea in JavaScript code so that he could create the concept of a garden, concept of plants in a JavaScript application, and then use Realm on the client side to store and synchronize this information. So this brings us to the fourth step, that it's configuring Realm Sync. So once Gabriele set up the rules and his application was ready on Atlas, he only needed to enable Realm Sync from the Atlas UI. So this as well was pretty straightforward. With a few clicks, selecting cluster, partition key, and permissions, he was ready to go. It looked very easy, to be honest, to him, but he was making a lot of progress, so he kept going. So with this, it seemed that it was working and syncing some data. So he got to this point and he wanted to understand what was next. And now that he had Realm Sync working and his application ready, what he could do with this. His idea was not just to do this for the sake of it, but make sure that he got value from the data. He's interested in the data, in the results of this experiment. So he realized that with a few steps, he was now using Atlas as a managed service for a database cluster that he didn't really have to manage. It had automatic monitoring and backup. And now Atlas was also managing mobile sync for him without too much complication. So he started thinking further ahead in terms of what was next. And remember, because he didn't have to manage the database, he didn't have to spend too much time configuring or managing how the data is synchronized. He could focus on what he really wanted. That was make use of the data, analyze the data, and create an application that will provide a useful experience, but at the same time value from what we can learn from that data. So his questions now were, how do we query and explore the data? Can we even do something like augmenting the data further? Or there is a concept of trigger. If only we could do something like reacting to data changes, that would be really cool. And then we will want to have some graphs showing the data and the progress from our results. So we will need to find some easy way to achieve that. So let's go ahead and see how we can explore the data. So you run the application, and thanks to Realm Sync, now the data is being synchronized in MongoDB. So once the data is synchronized in MongoDB, the data from the experiments, from the different Raspberry Pi devices, and the iPad sending information about each of the gardens, data was being synced thanks to Realm Sync into MongoDB and Atlas. So as for options to how to explore this data, he could either use the MongoDB shell. He was kind of confident that he could run some queries and see the data, but maybe he wanted something a bit more user friendly. So he downloaded Compose and started to play with it and was impressed about all the options he had to explore even further the data and define concepts like aggregations and see the data in a more visual way. But at the same time, that wasn't the only option. By going through the Atlas UI, I was able to see the option of data explorer in Atlas and how he could directly from the UI without any tool like the shell or Compose, he could straight away see the documents from the data that he was interested in. And he was really impressed with this and being able to access this directly from the UI. So he kept going, and after getting a good idea of the data and how the data synchronized looked, he started thinking of ways to expand it further. And he was aware of MongoDB aggregation framework and superpowers. So by going through the Atlas UI, he came across aggregation pipeline builder in Atlas. And this is really cool because it shows us the documents that we have in the collection, but it also allows us to define the different stages, and it will show us a preview of the documents in the collection. So what this means is that we have endless possibilities based on the data that we now have on MongoDB synchronized thanks to Realm Sync to expand further this data thanks to the use of the MongoDB aggregation framework. So for that, we could use options like $match and win group or any of the aggregation framework concept to even expand and augment our data. For example, grouping by garden or grouping by date, things like that, that could give us more insight from our data. In addition to this, there was this concept that he saw initially, and it sounds really cool, about triggers. And now that he was at a better point and he was trying to make sure the most of his data, started looking at triggers, and he saw that they were useful to react to certain events. So there were two options: database trigger that it's event-based, and then schedule trigger that it's based on a cron definition that will run on a regular time of the day, for example. And this concept of triggers can be useful to say, for example, to do an early data capture. We could react to events, and we could even add some intelligence to our data. So when reading this, Gabriele, with his brain always operating a bit ahead of him, thought like, what if we could set up something that when the temperature that we are monitoring and we have in our data is over 35 degrees Celsius, we will need to make sure that the plants will need some water. So we could make that happen based on the temperature. So, wow, we could call a webhook and get this to happen. So this sounds really exciting, because from the idea of monitoring the data and using this telemetry for the gardens, we could even trigger actions based on the data that we are reading live. So this was something like really, really exciting for Gabriel. And then continuing to explore like the Atlas UI and how we could get more and more information with his data that was continuously synced from the different clients and the Raspberry Pis on the different gardens that he was monitoring initially, how we could get more value from that data. So he came across charts. Charts is a product that is available from the Atlas UI. And with it, we can look at things like creating graphs for each garden based on the data we have. We can track the temperature and humidity, for example, on all gardens, and then even create a simple dashboard where we track their position and their conditions. So we can here like a simple graph where we are tracking in a very easy way, directly accessing the data on MongoDB. We can group by location, and we can see the date and temperature distribution of the different gardens that we had in our experiment. So this is like really easy. And for someone like Gabriele, that is a physicist and he is doing an experiment, it's a really easy way to visualize the data. And then, you could even integrate these graphs into a dashboard or the graphs on their own. And then it's very easy to share either via HTML or now even with the JavaScript SDK. So this was like really, really cool ending piece for his experiment, because it will allow him to create a very visual way to track the results of his experiments. And it was like the main thing that he wanted from his application, to collect all this information and then get an easy way to visualize the data and get value from the data for his research. So in summary, if we review Gabriele's story by using Atlas, MongoDB, and Realm Sync, we see what Realm Sync on Atlas really means is that it enables us to imagine what we can achieve by simplifying the user experience, by using multiple clients, multiple devices, iOS, Android devices, IoT like Raspberry Pis, and so on, and how it will help us to build faster and easier applications so that we can focus on the user experience. We will have reliable sync and conflict resolution without having to spend hours and hours implementing that. That's done by Realm for us and now integrated in MongoDB and Atlas. So the goal is, as we were saying at the start of this talk, that we can focus on the user experience and we can focus on the main value that we want to bring with our application and getting the value from our data in MongoDB thanks to the Atlas and MongoDB data flow platform and all the tools associated to it. So the next thing for me is to encourage all of you to play with Atlas, with MongoDB, and now with Realm Sync. Use your mobile devices, use the simulator, and get started to build your next idea. Thank you.